right, welcome ladies and gentlemen. This is video number 5 in our atomic theory, atomic structure unit. So you got to make sure you got your notes open to where it says video number 5. And we're also going to need a periodic table for this. We'll be doing a little bit of math too, but the math isn't crazy, so I feel confident you can do this without a calculator. In this one, we're going to start talking about electrons in a little more detail. We're going to go over the Bohr model and something called electron configuration. So our goals: describe how electrons are placed in terms of both distance and energy in Bohr's shell model. So we're looking, again, turning our attention sort of away from the nucleus and more towards the electrons. Electrons are more interesting anyway. They do lots of cool stuff. So Bohr, just a reminder that Bohr is the one who proposed the idea of that electrons exist in energy shells or energy levels. So he was the first one that said maybe there's some organization to the electrons and that they're not just random and all over the place on the outside of the atom. Now he abbreviated this energy shell, or this energy level, as N. So if you ever see like N equals 1, N equals 2, that's basically saying shell 1, shell 2. That's the number of the energy shell. And as a reminder, this is a big point. The energy level that has the least energy is closest to the nucleus, and the energy shell that has the most energy is farthest from the nucleus. So the closer your energy shell is to the nucleus, the lower energy that shell is. The further away from the nucleus you get, the more on the outside of the atom, then the higher the energy that the electron has in that particular shell. And electrons, they will always fill the lowest energy shells first. Electrons are lazy, man. They are lazy. They want to be in the lowest possible energy that they can be. So they are not going to start by filling shell 3. No. They're going to go right up to shell 1 because it's going to give them a lower energy. They're going to be more stabilized by the positive attraction from the nucleus. They're going to have that lower energy. The farther away they get, the higher the energy they're going to have. Things like to be in low energy systems. It makes them energetically stable. So electrons will always fill our lowest energy shells first. Each shell is numbered, right? So we have N equals 1, N equals 2, N equals 3, 4, 5, etc., etc. They can sort of keep on theoretically going forever. In actuality, we don't see them going forever, but theoretically, you can have an infinite number of shells. And more than that, Bohr also noticed that there was only a fixed amount of electrons per each shell. So you can't keep on putting electrons in shell number 1. Eventually, it hits capacity. And each shell, he figured out, can only hold 2n squared electrons. So whatever your n value is, square it, multiply it by 2, and that's how many electrons total can fit in that shell. So there is a pattern, and that's what we're going to look at here. So our principal energy level, remember that's n, and the number of electrons per that shell is 2n squared. So if n is equal to 1, then what we're going to do is square n, and then multiply by 2. So if n is equal to 1, 1 squared is 1, times 2, we can only fit 2 electrons in the very first energy shell. If n is equal to 2, again, we're going to do the same thing. We're going to square n, and then multiply by 2. So 2 times 2 is 4, and then multiply it by 2 is 8. We can fit 8 electrons maximum in the second energy shell. For n is being equal to 3, if we square it, 3 times 3 is 9, times 2 is 18. We can fit 18 electrons in the third shell. And for n is equal to 4, 4 times 4 is 16. Multiply that by 2, we get 32. 32 electrons fit in the fourth shell. We can fit more and more electrons per shell as we go out, but it's always going to follow this pattern in terms of the maximum number of electrons per shell. Now, a Bohr diagram is a way of illustrating this idea. It's a model. It's our kind of way to try to show what's happening with the atom. And it shows this idea of the electrons in shells. So, for example, if we want to draw a Bohr diagram that illustrates the electrons per shell for an atom of nitrogen 15, well, let's take the protons and neutrons first. So this is nitrogen. So nitrogen has an atomic number of 7, which means that there are 7 protons in the nucleus. So I'm going to call this innermost circle the nucleus and put 7 protons there. But it's nitrogen 15, so this is our mass number. So that is the number of protons plus neutrons. So 15 minus 7, there are 8 neutrons in this atom. So in the nucleus, we've got 7 protons and 8 neutrons. Now, this is an atom. So that means that our protons are equal to our electrons. So 7 protons means that we have 7 electrons. So I've got 7 electrons that I can place into this Bohr diagram, but the thing is, only 2 electrons fit in shell 1. And we always start by filling the lowest energy shells first. So we always start with shell 1. That's the one that's closest to the nucleus. So I'll even label them n equals 1, n equals 2, n equals 3. So I can only put 2 of nitrogen's 7 electrons in shell 1. But I'm not done with my diagram. I can't put any more in. It's full up. But I still have 5 to go. Now I can put up to 8 electrons in the second shell. Well, I only have 5 more to go, right? Because I need a total of 7 electrons. So I'm going to put the other 5 in shell 2. So 1, 2, 3, 4, 5, and that actually takes care of my Bohr diagram. So I knew that I had 7 electrons I needed to fill. I put the first 2 in shell 1, and I put the next 5 in shell 2, and I can actually write it, notate it this way. I can say that I can say 2-5, indicating 2 electrons in the first shell, and then 5 electrons in the second shell, right, in my Bohr diagram. And that is what electron configuration is, this idea of how many electrons there are per shell. In our reference table, the periodic table actually shows this. So if we look at phosphorus, for example, the lower left-hand corner, all the way on the bottom, if you use the key in the top of the page with carbon, it says that the thing in the lower left-hand column, all the way at the bottom, is the electron configuration. So that means that phosphorus's electron configuration is 2-8-5. What it always means, the first number is the electrons in the first shell in n equals 1. The second number is always the electrons in the second shell. And the third number is always the electrons in the third shell, and it keeps going and so forth and so forth. Our really large elements are going to have a lot of shells filled, but each number, each shell is separated by a dash. So 2-8-5 means for phosphorus that there are 2 electrons in the first shell from there. There are 8 electrons in the second shell, and there are 5 electrons in the third shell. So our Bohr diagrams are kind of a nice way of illustrating this idea of what's called electron configuration. How many electrons are there per shell? So just to close this out, we're going to sort of put this together with magnesium. We have an atom of magnesium. We're going to just draw one more Bohr diagram for it. So we want to start again with our protons and neutrons. So magnesium has atomic number 12, which is illustrated for us here. So that means that there are 12 protons in the nucleus. 12 protons. And then the mass number is 25. So this number is protons plus neutrons. So 25 minus 12 is 13 neutrons. So 13 neutrons in the center. And here's an instance where I'm actually going to have you go to your periodic table. And if you go to your periodic table, you look up magnesium, you look up its electron configuration that's on the reference table, you'll see that its electron configuration is 2-8-2. Well, what does that mean? How can we put that into a Bohr diagram? Well, first of all, it means that we have 12 total electrons. It means that we have 2 electrons in n equals 1, we have 8 electrons in n equals 2, and we have 2 electrons in n equals 3. So let's draw that. So again, the shell that's closest to the nucleus and lowest in energy is n equals 1, and the one that's farthest away, in this case, is going to be n equals 3. So I'm going to put 2 electrons in the first shell. I'm going to put 8 electrons in the second shell. 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to put 2 more electrons in the third shell. 1 and 2. And there is my Bohr diagram illustrating the electron configuration for this particular magnesium atom.